Okay, we begin by evaluating three functions: y equals x squared, y equals 1 over x, and y equals 2 to the x. We evaluate each of these when x is equal to -2, -1, -1/2, 0, 1/2, 1, and 2. These values for any of these functions will give us a very good picture of what the graph looks like. So, well, evaluating y equals x squared is quite easy. If we square -2, we get 4. Now, let me do this in a little more detail. -2 squared means -2 multiplied by -2. And of course, a negative times a negative is a positive, so that's a positive of 2 times 2, which equals plus 4. Now that's more detail than you probably need, but I'm going to use that detail I did in class because I want you to understand what it means to square -2 and how we're using rules that we learned earlier in our mathematics education. Negative times a negative gives us a positive. The square of a number is the number times itself. One thing that people will often do with -2 squared is they'll write -2 squared, they'll square the 2 and leave the negative. Now, of course, that is what it means if you write a -2 squared without any parentheses. If you put the parentheses around it, though, you're squaring the whole -2. So this is what we have. So we get 4. Now I'm not going to write out the details of the rest. Pretty clear we're going to get 1. Let's do -1/2 squared, though. This is going to be -1/2 multiplied by -1/2, which is going to be the positive of 1/2 times 1/2. Now people were unable to tell me, they were really afraid to try to tell me, how you multiply 1/2 by 1/2. What's the rule for multiplying fractions? Unfortunately, I don't find that overly surprising because fractions are totally de-emphasized in the elementary through middle school through high school curriculum. Put a calculator in people's hands, they don't multiply fractions, they don't use the rules for multiplying fractions. Get into algebra, they don't understand the rules for multiplying fractions, they memorize them for a short time, but it's not really something they understand deeply, and that shows up when I ask people to do something like this. You want to understand these things at a deeper level. You want to really understand these rules. And the rule for multiplying fractions is you multiply the numerators, and that gives you the numerator. You multiply the denominators, and that gives you the denominator. The multiplication rule is simpler than the addition rule, and the two are often confused, and we really don't want that to get in our way when we're doing these things. Okay, so this is going to be 1 times 1 divided by 2 times 2, which is, of course, 1/4. So now we have 1/4. Okay, if we square 0, we get 0, and then the rest of the numbers come out much the same, very straightforward. So here are the numbers. Now, we're going to use these numbers to construct a graph. Okay, and the first thing I ask you to do is sketch a graph of an x-axis with the numbers -2 through 2. These same numbers here. Okay, -2, -1, -1/2, 0, 1/2, 1, 2. Okay, now I'm going to do something that's very wrong and see if you can understand what's wrong about it. Okay, I'm going to put -2 here, -1 here, -1/2 comes next, and now 0, 1/2, 1, and of course 2 is going to be out here. I didn't leave myself enough room, I made my scale a little bit too big. What's wrong with this? Can you see what's wrong with it? Okay, a very serious error here that totally distorts the shape of any graph. Okay, well, what's the distance from here to here? From -2 to -1, the distance is 1. Okay, if you go between 2 mileposts, of course you're not going to have negative mileposts on the interstate, but if you go from 1 milepost to the next, you've gone a mile. You've gone 1 unit. Okay? And what else? Well, let's see. From -1 to 0 should be a distance of 1. Okay, well, right away, if we think about it, we see that we're in a little bit of trouble because this is supposed to be a distance of 1, and this is supposed to be a distance of 1. Are these both? Distance is 1? Question mark? Well, clearly, according to the scale of the graph, they are, but this distance is greater than this one. So this is not correct. So I have to say, well, no, this doesn't work. They can't be, the scale is wrong. So we have a bad scale here. Now do you see what to do to correct that? Well, I'm going to put a big X through this, indicating that this is not the way we do it. Okay, now down here, I'll correct it. And what I'm going to do is I'm going to put 0 here, and I'm going to put -1 here, and -2 here, and 1 here, and 2 here. So I've got -2, -1, 0, 1, 2. And then halfway between 0 and -1, that's where -1/2 goes. Okay, the distance from 0 to 1/2 is not the same as the distance from 0 to 1. Well, let's look. From 0 to 1/2 looks like it's the same as the distance from -2 to 1. Well, these distances have to be to scale. And the distance from 0 to -1/2 is half the distance from 0 to -1. So right here is how we would draw these X values. Okay, now I want to draw a Y-axis, so I can put a Y scale on this. Okay, so here's a Y-axis. Now I'm going to label the Y-axis with 4 up here and -4 at an equal distance down here. And if I subdivide this and then subdivide again, well, I didn't do a very good job of it. My units keep getting smaller. But if I do this correctly, and do it carefully, I'm going to have 1 here, 2, 3 here, 4 here. Okay. Now I'm looking down at the board and I wasn't careful about how I subdivided this. So this distance 1 is significantly smaller than this distance 1. That's going to distort the graph. When you draw it, do a better job than I did. Okay? The other thing is that distance of 1 on the x-axis is quite a bit bigger than any of these distances here. Well, that's kind of okay. Your distances on the y-axis don't have to match the distances on your x-axis. In many cases they should, and for this graph they probably should, but I'll leave it to you to draw it that way. Okay? Now, we want to sketch the graph. So we want to locate the points corresponding to the x and y values. When x is -2, y is supposed to be 4. So let's see, x is -2 all the way along this vertical line here, all the way up and down, and y is 4 all the way along this line. So this is a line x equals -2, and this is the line y equals 4. And the point -2, 4 lies at, well, where these two lines intersect. Okay, so there's a picture of the point -2, 4, and I'll go ahead and kind of label that. I didn't leave myself a lot of room, but here we go. There's -2, 4. Okay, and then we have -1, 1. Well, let's see, x equals -1 lies along this line, and y equals 1 lies along this line, and those two lines intersect here. So here's our point -1, 1, corresponding, of course, to these x and y values. And then the point 0, 0, or the point -1/2, 1/4. Okay, kind of running out of colors here. think I've run out of colors. I'm not going to be able to color code every point. But I'll draw my line x equals negative 1/2. And a line x equals 1/4. Well, I take this 1 and cut it in half, and I've got a half. I take that and cut it in half. I've got a fourth. So my x equals 1/4 line, y equals 1/4 line, lies here. And the two lines, x equals negative 1/2, y equals 1/4, meet here. Now my remaining points I'm just going to draw in white, and we know how to graph points. We wouldn't be in this course if we didn't, but I want to make sure we have a really solid foundation for doing the things that we're going to do later on in the course. So I'm not going to label every point, but right here are the 7 points that correspond to this table. Okay, so, and if I want to, I can sketch a smooth curve through these points. And this would be the graph of y equals x squared.